hour, right? 1 hour. I hope you get a good grasp, right, about the concept of confidence interval estimation. So if you know that, estimating percentage will be very easy now, okay? Here, if we want to estimate the percentage of certain category in the population, I call it P. Some of the book use pi. It just stands for population proportion, proportion of particular category in the population, right? Here, I use an example, percent of people who have no insurance coverage, right? And so there is a population there, and in this population, there's got to be a particular percentage of people who have no insurance. I don't know exactly what that percentage is, but I can estimate it, right? So what I do is I take a random sample and sample size n and found out that X of them actually have no insurance. So X divided by n, this gives me the proportion of people who have no insurance from the sample. So I call it the sample proportion, okay? So I hope you understand the meaning of X and N, right? That gives us the sample proportion. Now, if I code this sample proportion as 1 or 0, okay, like Bernoulli distribution have 1 or 0, right? I code data 1 or 0. Then, for instance, my data, let's say 1, 0, 0, 1, 0. That means I have 2 that had no insurance and 3 had insurance. So what's the proportion of no insurance? Actually is what? You count how many of them have no insurance, divide by 5. I'm sorry, this should be, actually, I thought that's, I changed that. I still like that. Huh. This should be 4, right? Oops, I changed the color too. I guess it's okay. What did I do? Okay. Maybe I go back. Okay. Well, anyway, you got the idea. Okay. So what I'm trying to say is, when you calculate average for this data, it is the same as the proportion of ones. You see that? So if you code your data as 1 and 0, the sample proportion is the same as sample mean. Okay? Make sense? Okay? And you know that distribution of sample mean, when sample size is large, what's going to happen? When sample size is large, regardless of what kind of population you're taking your sample from, the sample mean, it will be approximately normal, which tells us that sample proportion, this quantity, when sample size is large, the sampling distribution of sample proportion is also normally distributed. Ah, that's great. We know normal distribution a lot, right? We just study it. So based on that, we can go through the same reasoning to actually construct the confidence interval estimate for proportion using sample proportion, right? This quantity here is actually the standard error for the sampling distribution of sample proportion. A statistician derived this result, right? You can also use the data S over square N if you have sample data. They should be very close, okay? And we say that when sample size is relatively large, sample proportion follow a normal distribution, right? So approximately normal, so we just use that when confidence level is given, since it's normally distributed, right, we can just figure out the z-score for any given confidence level and use that to multiply standard error to determine marginal error, just like what we did earlier, right? So this is actually the confidence interval estimate formula for estimating proportion. This is one version, though. There's another version. The formula looks very complicated. They call it unbiased estimation, using unbiased estimation, but it's generally not covered in the introductory class, right? It's a pretty complicated formula, right? I will mention that now. When you use R commander to do that estimate, confidence interval estimate, it actually gives you the result from that formula, okay? But there is a package that actually can give you a result from this. I call this asymptotic, using asymptotic method, right? When the sample size gets large, proportion actually sample proportion approximately normally distributed. Right? Anyway, this is an example, right? So the formula is this one. I think you know how to apply this. You know sample proportion based on your data is plugging in there. Then what you need to do is find out that z-score using a standard normal table or using software. Right? You'll be able to find the z-score correspond to the given confidence level. Right? So look at this one. You have a sample of 400 from a large community. And it shows that 32 of them have diabetes. And you want to use this data to estimate the proportion of people who have diabetes from this population. Okay? So what do you do then? You know the sample size. In that formula, you need the sample size. You know the sample proportion. You need also the z-score. And you see how to find the z-score earlier, right? When you have 95%, you want to cover 95% of the center, the z-score is 1.96. So what you do is just plug those numbers into the formula. 1.96 here, sample proportion 0.08 in here for p, sample size for n. Okay, plug those numbers in. You get 0.08 plus minus 0.027. That's the margin of error. Of course, we're estimating percentage. We can convert proportion notation to percentage. So it's 8% plus minus 2.7%. Right? This is using point estimate plus or minus margin of error. You can actually use an interval notation. Just use a point estimate and subtract that, point estimate plus that to get the left hand and right hand point on the interval. You got to know these two notation. Right? You should be able to flip between these two. People give you the bottom one, you should be able to flip it to the top one. Right? When people give you the bottom one, you don't see the margin of error, right? A lot of times people like to see what's the margin of error. Is it large or small, right? If that's the case, you can actually margin of error is what? Half the size of this interval, right? So if you find the length of this interval divided by 2, you get margin of error. Okay. So when you get this, or you get the confidence interval estimate for mean, how do you interpret this interval then? If you do it this way, you can tell people that if I use 8% for estimating the percent of people who have diabetes in this community, then I can be 95% sure that the maximum error that I make is 2.7%, right? Or I can be 95% sure that my margin of error is 2.7%. Okay. If you use the interval notation, you can tell people that I can be 95% sure that the actual percent of people who have diabetes is in between 5.3% to 10.7%. Right? So it depends on how you present them. Right? Each have their own advantage, right? Or different information that you can explain. Okay? And same thing, there's sample size issue. So if you don't want margin error to be too big, how can you do to produce a sample size? Right? So when you go out, you can just collect that many data and come back. You won't miss the goal for margin of error. Same thing, I can set margin of error equal to this margin of error formula. Right? So E is margin of error. Set it equal to this margin of error formula. Solve for n. I actually come up with 2 formulas. If you do have some pilot study done in the past, you can use the pilot study result to estimate the p-hat and to estimate the sample size. Right? Now, and sometimes you probably don't have any information. Right? You've never done this study. Then what you can do is actually maximize this quantity. This quantity, P is probability percentage, is always a number between 0 and 1. Right? This expression is maximized when P hat is 0.5. Okay, so 0.5 times 0.5, you get 0.25. So you can use this formula too, if in case you don't have any prior knowledge about proportion. Okay, so you have these formula to help you to figure out sample size before you actually go out and get the data, right? To do margin of error, to do confidence interval. So here's an example. I want to do a 95% confidence interval, confidence interval. I want the margin of error to be no more than 3%. And there's no prior knowledge about P. Right? So what should I do? I use that second formula. Since it's 95%, my z-score is 1.96. Right? Margin of error is 0.03. So I just plug those into the formula and multiply 0.25 instead of p hat times p hat. And 1 minus p hat, right? Because I don't have p hats. So I get a 1067.11. Of course, again, we round up to the next higher integer. So you need 1,068. Okay. Now, if you probably realize when you listen to the news, TV reporting the result from maybe pre-election study, oftentimes they tell you that the estimate has a margin of error of 3%. That kind of tell you also they probably use 1,000 data. In fact, they really use 1,000 pieces of data, right? And so when you have 1,000 pieces of data, your margin error will be no more than 3%. Okay. Now, what if I do have some prior information? I've done some study and sample proportion was 6. This is 6, actually. Usually, I don't like small proportion, right? Small proportion sometimes make the estimation not as good. But here, just an example. Suppose I have that proportion information. Then what should you do then? Instead of using 0.25, you plug in p hat for proportion, right? then you get a sample size 240.7. Wow, you see, both we ask for margin of error 3%. But with the prior knowledge, I actually can reduce my sample size from 1,000 to 200 something. Okay, so knowing some information will help. And here, in this case, I'm probably reducing the time and cost for you to actually produce an interval that will achieve that same goal. Okay, so again, we run up to the next higher integer. So I have 241. Okay, make sense? Okay, let's see. In my on Springboard, I actually give you a another lecture note, right? That showing you 4 pages of practice problem. Let me show you here on Springboard, right? The Springboard lecture note section, the 3rd item, I believe, right, is related to. Is about this set of exercise problem. And I actually shown this example every semester. So if you go down further in the Springboard page, you find out other video links that actually talk about this and actually give you the lecture I gave in the previous years, right? So if you don't like today's lecture, for instance, you like to see more, you can go there to view more lectures, right? To see my different lecture talking about the same thing, though, okay? Okay, so let's look at this example. I have data here, 9 subjects. I want to estimate the average heart performance index for the population where the sample is from. Okay, so I have 9 pieces of data, and I want to find a 95% confidence interval for estimating that. What should I do? It's a small sample. Okay, so we just learned the formula. Yes, somebody want to say something? Anybody? Okay, probably, yeah, okay. Be careful, sometimes you maybe just not intentionally just press that button, right? Just press it back, all right? Okay, so this is a small sample. We just learned the formula, right, for estimating mean. That was, let me go back to this. That was this confidence interval estimate for mean, right? Okay, so you need to figure out sample size. Oh, actually, it's there, right? It was 9 pieces of data. You have to calculate the standard deviation from your data. You have to calculate the mean of the data. And you have to find the correct t-score corresponding to the degrees of freedom, right, for that problem. Sample size 9, degrees of freedom is n minus 1, 9 minus 1. So degrees of freedom is 8, right? So you can look up a t-table for that degrees of freedom. Okay. So for this problem, actually, let me do this, right? So you want to apply that formula. That t-score times s over square root n. And I actually calculate the mean and standard deviation for you, right? But in practice, if you do your own problem, let's say for web design, you need to calculate this yourself, right? So that give you mean is 6 plus or minus t-score. You got to look up the t-score from the chart, right? Standard deviation is 0.87. And divide by square root of 9. So what is that t-score? 95% degrees of freedom is 8. So you go to that t-table from the maybe ebook, right? 95% degrees of freedom 8 is actually 2.31, right, from that web assigned book. So 2.31. And you're almost down. This part here is the margin of error, okay? This part is about 0.67, right? So you have 6 plus or minus 0.67, and that's your confidence interval. Okay, you can convert it to 5.33 and 6.67 as a 2 endpoints. So you finish your problem. That's just very simple, right? Of course, this is a small sample situation, so there's one condition you need to check, right? What's the condition? Anybody? Normality, that's right, right? You want to check for normality, and that's not too hard, right? You can do that with the R commander. Okay. Okay. Any question? Now part B, let me change to another pen. This is not dark enough, right? Okay. So part B is a finding sample size problem, right? How large a sample size be needed if my margin error would be within 0.2, right? So sample size formula is n is equal to that z-score square and the sigma square and also margin error square, right? Or you just say find all these and square the whole thing, right? That's another way to do this, right? You figure out all these and square the whole thing, right? So what I do, well, since it's 95%, the z-score is 1.96. And sigma was given, that was around 1.2, okay? And margin of error, we need it to be 0.2. So you have all these and squared it. You get 138.29. Of course, you want to round to 139. That's it, okay? You get the sample size that is needed, right, for taking care of this problem. Okay? Questions? Any question? Okay. Good. Let's look at the next example. I'm trying to estimate the percentage of people who actually ate dinner mostly after 8 p.m., right? That's not good, right? Almost too close to your sleep time, right? I used to do that, and I tried to change that, right? So I've been doing better now, okay? But anyway, you want to estimate that, right? What percent of people who actually behave that way, okay? So you surveyed 300 subjects from this city, and 170 of them responded that they had their dinner after 8 p.m., right? Probably big city, often people do that, right? So I want to construct a 95% confidence interval estimate for that, okay? And how do you do that? Well, this is a confidence interval estimate for proportion, right? So you should use a formula that is for confidence interval estimate for proportion. That is actually a formula you use z-score, okay? That's a formula. You can look up our notes, right? So what is the p-hat then? P-hat here is 170 out of the 300, right? Okay. What would be the z-score for this problem? Again, it's 95%. You don't have to look up a table. After a few problems, you probably have that memorized. That's 1.96. Right? Okay. So what you need to do then is just let me make this. This number is actually, let me see. Do I have a fraction? Okay. This is 0.5667. So 56.67%. Right. So what I can do is just plug in this formula, 0.5667 plus or minus e equal 1.96 times square root of 0.5667. 1 minus 0.5667 divided by 300. So this number is 0.0561, right? So I will have 0.5667 plus 0.0561. Or if you convert it to percentage, 56.67% plus or minus 5.61%. That will be your answer, right? Or you can convert it to actually interval notation, that is 51.06% to 62.27% if you want. Okay? So that's how you do this problem. It's really not hard. Okay? Today I mentioned those concepts, how you construct these, develop this or construct these intervals, right? But when you actually try to apply it, it's very simple, right? I think the most important part, difficult part probably is finding these z-score or determining which formula you use. Okay. Okay. And the next one, again, sample size issue, right? If I want to do this estimate with margin error of 5%, and I have no prior knowledge about proportion, for instance, right? If that's the case, what should I do? No prior knowledge, that's fine. If I know my z-score margin of error, I square that times 0.25. I will be able to get it, right? So z-score for 95% is 1.96. marginal error I want is 5% and 0.05. Square that times 0.25, I will get the sample size. So that is 384.16. If I raise it up, I'm going to round it to the next whole number. So 385. If I have this many subjects, I'll be able to achieve my goal in terms of marginal error. Okay? Now, if I do have some prior knowledge about proportion like this next problem, then I will just use the second version of the formula. Z-score margin of error, square that, time p hat, 1 minus p hat, right? You know what p hat is, right? P hat here is what is given, 60%, right? Prior knowledge, right? So 1.96 divided by 0.05, the z-score divided by margin of error, and 0.6, 1 minus 0.6, and you multiply this out, you get 368.9 raised to 369. So with the prior knowledge, proportion 60%, I actually save a little bit. From 385, I can reduce the sample size 369, right? So it's around like maybe almost 20 counts, okay? Any question? Okay.